All right, welcome to the Pre-algebra 4.7 video. Today we are talking about the concept or topic of scientific notation. Now I have a feeling you've probably seen scientific notation before, but if you haven't, let me show you an example, okay? 7.25 times 10 to the fourth. 1.007 times 10 to the negative third. How about 9.974 times 10 to the 120th, okay? So those are all examples of something or numbers written in scientific notation. All right, now what do we notice about these? Is there any common trends? Well, we see that they are all being multiplied, or you have some number that's being multiplied. Okay, so multiplication is a common thing. Now, what are they being multiplied by? Well, they're all being taken times 10 to the some power, right? Now, notice that is a integer of 4. That's an integer of negative 3. That's an integer of 120, right? So they're all taken to the power of some integer, otherwise known as a positive or negative non-decimal number. Okay. Now the other thing that isn't proven here, but we do see, is that this number right there is greater than or equal to 1, but it's also less than 10. Okay. So let me show you kind of algebraically what scientific notation is. Okay. So you could denote it as C times 10 to the n. Okay. C times 10 to the n. These are all in C times 10 to the n format. All three of those right there. Okay. So the rule is that C, which is that first number, okay, is greater than or equal to 1, but it's less than 10. Okay. So that number has to be greater than or equal to 1, but less than 10. And then again, so we could say that's rule number 1. Rule number 2 is n has to be an integer. Again, what's the definition of an integer? It is a positive or negative non-decimal number. All right, and so this whole thing, we'll call this item number 1. Now, down to item number 2. All right, so is 34.7698 times 10 to the negative third in scientific notation. So think about that for a sec. Look at what you just wrote down in your notes about the rules and come up with an answer. Well, I hope you said no. Now, I'm really less concerned that you know the answer. I'm more concerned about why. Why is it non-scientific notation? Can you have something times 10? Yeah, you must have something times 10, right? That's the good part of this. Can you have something to a negative exponent? Absolutely you can. Negative 3 is fine. But how about the 34.7698? 34.7698. This is the issue, and why? It is not between or greater than or equal to 1 or less than 10, right? It doesn't fit this rule, okay? It cannot be greater than 10. It has to be less than 10, and 34.7698 is significantly greater than 10. So that would not work, okay? Now, if you had, I'll rewrite it, 34.7698 times 10 to the negative 3, is that an actual number? Yeah, actually it is, okay? That is a real number, but it's not in scientific notation. So what we're going to learn next is how to put things into scientific notation. All right, so putting things into scientific notation. Now, why would we want to do that? Well, scientific notation is used to represent really big or really small numbers. All right, and by really big and really small, I mean they don't have to be like in the millions and billions or like 0.00000000007 or something like that. We can put pretty much anything in scientific notation, but we use it for, let's say, bigger and smaller numbers. How about that? So, for example, 3,000. If I wanted to put that into scientific notation, what would I do? Well, let's go back and look at what some things in scientific notation look like. All right. Again, these numbers were greater than or equal to 1, but less than 10. And it was all times the number 10 to some power that was either a positive or negative non-decimal number. Okay? So the first thing we need to do is identify where the decimal is in 3,000. Well, we know it's right there. Okay, it's the invisible decimal. Now, we need to get this 3,000 to become a number that's greater than or equal to 1, but less than 10. So if I move this guy one space to the right, what that actually does is become 300 times 10 to the first. Okay, when you move your decimal one place to the left, for every time you move it one place to the left, you gain 1 in the exponent. Okay, but it's still not in scientific notation because it's 300. It's not less than 10 or greater than or equal to 1. So let's move it one more. Now it's 30, and since I moved it one more to the left, I need to make this exponent now a 2. And, but it's still 30.00. That number is not less than 10 or greater than or equal to 1. So let's move it one more space. And because I moved it to the left one more, that goes from being a 2 to now being a 3. Okay. Now what is our number? Well, the decimal is now here, and I'll rewrite what we currently have. Now it's 3.000. I don't need all those zeros. I just need one of them. Times 10 to the third. Is this in scientific notation? Yeah, this number is greater than or equal to 1, but it's also less than 10. Good. Times 10 to the positive 3. That's a perfectly legitimate answer, and it's the correct answer. So what are we seeing here? Well, we're seeing a larger number, okay, so a number that is greater than 10, actually, that is then being represented by a smaller number, right? We go from 3,000 to 3, but we compensate for changing this 3,000 to 3 by adding a positive exponent, okay? So when you have a number that is greater than 10 that you're starting with, you're going to put it in scientific, I should say greater than or equal to 10. When you start with a number that's greater than or equal to 10, and you're going to put it in scientific notation, you're going to represent it with a positive exponent, okay? Now, if you start with a number that's smaller than 1, okay, so we're using our rule up here, this one right here, okay? When we start with a number that's smaller than 1, such as 0.54, and we want to represent that using scientific notation, we are going to use a negative exponent, okay? So if I was to put this in scientific notation, I would need to get it to look like some number times 10 to the some exponent, right? Well, this number needs to be greater than or equal to 1, but less than 10. So if I move this decimal one place there, that now changes it to a 5.4. And the exponent becomes, well, 5.4 times 10 to the, well, I moved it to the right. And when I have something and I'm putting it into scientific notation, and I'm moving the decimal to the right, I get a negative exponent. I moved it 1 to the right, so it's a negative 1. All right, and so what I want you to notice is when you have a number you're starting out with that is less than 1, you're going to use a negative exponent. When you start with a number that is greater than or equal to 10, and you're putting it in scientific notation, you're going to end with a positive exponent. So I want you to take a second and let's see, I want you to try these two. So 4 and 5. I want you to put both these into scientific notation. Alright, so take a minute, work on those, play the video when you're done. Alright, so here I have a number that is greater than 10. So I automatically know I'm going to put it in scientific notation and I'm going to have a positive exponent, right? So it's going to be something times 10 to the something, and this thing's going to be positive. Alright, so where's my decimal here? Well, it's right there. And I need to get that number from 27,131 to something that is greater than or equal to 1 but less than 10. So let's move the decimal 1, 2, 3, 4 places. Okay, so now I have 2.7131. Okay, let's pause. Is that number greater than or equal to 1 but less than 10? Yes. Good. Now how many places did I move it? 1, 2, 3, 4. 4 places. Okay, and again, I'm representing a large number with a smaller number, so I'm using a positive exponent to compensate for that. Now down here, I'm going to do the opposite. I have a number that is less than 1, okay, significantly less than 1. So I'm going to turn this number that is less than 1 into a number that's between, it's going to be greater than or equal to 1 but less than 10. Right? Which means when I am doing that, I'm representing a really small number with a bigger number. It's going to be something times 10 to the negative, okay, that's the key. So how many places do I move this decimal? Let's see, 1, 2, 3, 4. Now I've got myself to the number 4.704. That number fits our rule because it is larger, greater than or equal to 1 but less than 10. How many places did I move it? 1, 2, 3, 4, so we get a negative 4 as our exponent. All right, so now we're going to work on going from scientific notation to standard notation. Okay, so we have 3.2, say, times 10 to the 7th. All right, it's in scientific notation, we can see that, but I want to put it in standard notation, or just, you think of it as regular notation. I just want to make it a number. All right, so how do I do this? Well, I'm going to kind of do the opposite, but as what we did before. But before I do that, let's think about what we have here. I have a number that's, it's between 1 and 10, or greater than or equal to 1, but less than 10. And it's times 10 to the positive 7, okay? When I have a positive exponent, this means I'm representing a number that is bigger than 3.2. If this was a negative 7, I'd be representing a number that is smaller than 3.2. But it's positive, so it's representing a number that's bigger than 3.2. So I'm going to take my 3.2, and I'm going to move my decimal how many times in what direction? Well, I'm going to move it 7 times, and I need to show that this is representing a large number. So if I moved it to the left 7 times, that would be representing a small number, wouldn't it? Yeah, I don't want to do that because it's actually representing a large number. So I'm going to move it 7 places to the right. So 1, 2, 3, 4, 5, 6, 7. All right, what do I do with all these gaps? I'll fill them in with zeros. 1, 2, 3, 4, 5, 6. All right, so what number is this actually? 3, 2, 0, 0, 0, 0, 0, 0. So 1, 2, 3, 0, comma, 1, 2, 3 zeros, comma, 32 million. Okay, that is 32 million in standard notation. So I want you to try number 7. I want you to write this. It's going to be in scientific notation. I want you to write it in standard notation. Take a minute, put that in standard notation, see what you get. All right, so hopefully you remembered that, when you have a number in scientific notation with a negative exponent, it means you're representing a number that is smaller than 4.3179, okay? Which means if you're going to take it from scientific notation and put it into standard notation, you're going to have to move your decimal to the left. So I'm going to rewrite the 4.3179, and I'm going to move it 4 places to the left. So 1, 2, 3, 4. Fill in the gaps with zeros. My final answer is 0.000431799. Those two are the same exact thing. This is scientific notation. This is standard notation. All right, guys. Well, that is all I have for you. I look forward to seeing you in class.